Hello and welcome to part 2 of my videos on how to incorporate Arduino with 3D prints. Now before you begin coding, you need to make sure that you actually have the Arduino microcontroller and you have the Arduino IDE software already downloaded. If you do not have the Arduino software already downloaded, follow this quick simple steps. Just search Arduino IDE, download for your operating system of choice, just download or contribute, and we'll be on our way. In case you've never used Arduino IDE before, here are a couple of quick basics. The setup function is where we input all of the information that the microcontroller needs to know on its first turning on. The loop constantly runs throughout the entirety of the machine being on. In this drop-down, you will choose your board that you have purchased in order to have the correct code be sent out to the board. Now we're going to jump right into coding. If you have never coded before, Arduino is case sensitive, so make sure you follow along exactly how this is input. The first command we put is pin mode, and that is telling the Arduino for this specific pin, we are going to be using output. The pin we are using is the LED built in. That is port number 13 on your Arduino microcontroller. Now, as I mentioned earlier, this code will run only one time because it is in your setup function. Now we are going to jump into the loop function. This will run continuously and loop over and over and over again as long as the microcontroller is plugged into a power source. The next command we use is digital write. Digital write controls a pin and sends it the signal of either high or low. The next command we are sending is delay. That is telling the Arduino to wait 1000 milliseconds before executing the next command. Again, after that, we are performing the digital write and sending it the low signal. Now, the difference between the high and the low signal is the amount that it sends through. The high signal will turn an LED on, and the low signal will essentially turn the LED off. This works because it is adjusting the amount of voltage that is being sent through the circuit. Now you see here in my codes, I am writing 2 forward slashes followed by notes about each of the command line. Those slashes allow us to make notes without having the microcontroller actually try and execute those words. This comes in extremely helpful as you develop more and more complex programs. You don't forget what you write. Now that the code is complete, it's on to making our circuit. In order to do this, you'll need your breadboard, these jumpers, your Arduino that you want to use, you'll need the 220 ohm resistor, and one colored LED. Now when I create these, what I try and do is go in the path that the circuit will take. So first, we start from the pin that we need to use. For this, we use pin 13. That is the built-in LED as well. Next, we need to put our resistor in. Now, if you haven't used a breadboard before, each one of these groups of 4 are all connected together. Then each of these columns on the bottom are connected the entire length of the board. So let's plug our resistor in the same group of 4 next to our jumper cable that we have plugged in from pin 13. Now these can be finicky sometimes, especially when you're using your breadboard for the first time. Sometimes it needs a little bit extra breaking in. Then connect it to another group of 4 a couple of pinholes over. This will allow for some extra working space. Once the resistor is in, we're going to grab our LED. You'll notice that the LED has 2 different length leads. The longer one is the positive side, and the shorter one is the negative side. Because current flows from positive to negative, we plug the positive side into the same group of 4 as the resistor. the negative side will go in a different group of 4 pins. From there, we take another jumper and plug that jumper in the same group of 4 from the LED to the 5-volt ground pin on your board. This will complete the circuit. From here, we plug our Arduino into our computer and then hit the compile button. That is the check mark in the top left of the Arduino IDE. What this does is it makes sure that there are no errors in anything that we have coded up. Once it compiles correctly, you hit the right arrow key and it will send our code off to the board. So when we will plug it in, it automatically executes. Here, you can see our light blinking on and off, just as we have it coded up. Great success. Now, ships use a different way of communicating. They can use Morse code. So, we have our delay times, and we can easily adjust when we turn on and when we turn off the lights. For our example, we will be using the letters B and Z, Bravo and Zulu. For the letter B, it is a dash, dot, dot, dot. Now we will want our dashes to be a little longer, so we will have a delay of 500 milliseconds before we turn it off. And we only want it off for 200 milliseconds, so that way we can tell it's still part of the same letter. For a dash, we will use 200 on and 200 off. Copy and paste those commands, and you can have your dash, dot, dot, dot very simply. Now between letters, we're going to add a longer pause, and that way we can tell it's a different letter. For that, we will go back and use 1,000 milliseconds. Next, for the letter Z, which is Zulu, it is a dash, dash, dot, dot. At this point, we can grab the commands that we want, copy and paste them from the top, and make sure that we add that delay time at the very bottom of the letter Z. That way we know there's a B and a Z. And now when a ship signals Bravo Zulu, it is really saying, hey, you did a great job. Just like you did a great job following along with this video and this tutorial for so long. Thank you very much. So let's compile our code and send it on out. And once it sends out, it will automatically begin to run your code. Bravo Zulu. Now I have a male to female jumper cable, which allows me to plug in the LEDs to that jumper cable instead of the breadboard, which makes this a lot more simpler to assemble. Congratulations on integrating your microcontroller with your 3D print. Thanks again for watching. I am 3D Hack. Be sure to subscribe and follow.